In this video, we'll be using our integral formulas. If you've not already done so, take a moment to copy these formulas down in your notes. Our problem is to evaluate the integral of t dt divided by the square root of 1 minus 7t to the fourth power. Now our first thing is to decide which formula that we need to use. Notice that we have a radical in the bottom, so we're going to either use the first one or the third one. And I do not have any factor out in front of the radical, so I will be using the first formula. So I'm going to rewrite my problem so that it fits this formula. So I'm going to just copy the t dt, and in the bottom I'll rewrite that as square root of, and then I need a constant squared, so 1 squared, and then minus something with the variable in it squared. So this will be the square root of 7 t squared quantity squared. So I'll let u be my root 7 t squared. So du is equal to 2 square roots of 7 t dt. Now I have t dt up in the numerator, so I'm going to multiply both sides by 1 over 2 root 7. So I have 1 over 2 root 7 du is equal to t dt. Now I can sub back in here. This will be the integral of, and in place of t dt, I'll put in 1 over 2 root 7 du, and in the bottom I'll have the square root of 1 squared minus, and then root 7t squared, remember we said was u, so u squared here. I can bring this constant out in front of it. So I have 1 over 2 root 7 integral du over radical 1 squared minus u squared. So now we can see by our formula that this is equal to arcsin u over a plus c. So this will equal arcsin u was root 7 t squared over, and then a was 1 plus a constant, and then I also have to write my 1 over 2 root 7 out in front. So just a little bit of simplifying here. This 1 doesn't need to be written. So I have 1 over 2 root 7 arcsin root 7 t squared plus a constant.